Uh, Hello, hi. So today I'm going to discuss a CHP plant related problem, right? The question is already attached, right? The link of the question is attached, right? So you can follow the link and read the question, right? So this is a kind of a very complicated problem, right? So you have to solve very carefully, okay? Right. So first of all, go through the link and study the problem, right? So now let's start. The first part that they are asking is uh, find the boiler efficiency and the electrical power generation. Okay. So the first part is to find the boiler efficiency. Let's see how to do that. Now, in this problem, right? After studying the problem, you will see that uh, the information of the fuel, right, is given based on the dry basis, right? 100% dry basis. But in reality, in this problem, they are using fuel with 50% moisture content, right? So you have to solve according to that, right? So then in this problem, they have given us the lower heating value of so they have given lower heating value of the fuel on dry basis is 17.9 megajoules per kilogram. Okay, right. Lower heating value dry basis, right? That means with zero moisture, right? Is given 17.9 megajoules per kilogram, right? But we need to find what is LHV with 50% moisture content, right? So that is the target, right? So now the first thing, I will directly go to the steps, right? So now the first thing that you have to do in this problem, the fuel properties are given, right? So LHV 100% dry basis is given. So now you need to find what is the higher heating value HHV dry basis, right? First of all, you have to find this higher heating value dry basis, right? Or in other words, with no moisture content, right? Okay, so that equals lower heating value dry basis with no moisture content plus, right, plus heat of vaporization of water due to, right, due to moisture content and due to formation of water from hydrogen, right? Because this fuel contains hydrogen, right? So the high heating value equals lower heating value plus heat of vaporization of water because of the moisture content of the fuel plus water that is formed due to the hydrogen, right? That is included in the fuel. So that equals this, that is 17.9, right? Okay. Plus, keep in mind the units are megajoules per kilogram. How to find this? Okay, 2.4 times what is 2.4? 2.4 is the heat of vaporization of water, right? This 2.4 is the heat of vaporization of water. Within brackets you have to put hydrogen content in the fuel. What is the hydrogen content in the fuel? 6.1%. So 6.1% means it is 0.061, right? Because the hydrogen percentage is 6.1%, so that means it is 0.061 divided by molecular weight of hydrogen, right? Considering for kilogram mole, 2 kilograms per kilogram mole or kilomole multiplied by molecular weight of water, 18 kilograms per kilomole, right? And now let me tell you one thing. Now we are going to consider for dry basis with no moisture content, right? Because that means initially in this world it doesn't contain water because it is 100% dry. So that means the heat of vaporization in this scenario, right, is only because of formation of water from hydrogen, because initially this doesn't contain moisture, right? So you don't have to waste your burning heat in order to vaporize water, right? So here you only have to worry about heat of vaporization due to formation of water with hydrogen percentage of the fuel. Understand? Right. So if you solve this carefully, the answer that you are getting, you have to be very careful about the units. Okay, 19.22 megajoules per kilogram, right? Okay, so now we will write that value somewhere. Higher heating value at 100% dry basis is 19.22 megajoules per kilogram. Let's put a star. Now I will erase this. So now you need to find what is the higher heating value, right? Considering 50% moisture, right? So now you have to consider higher heating value considering 50% moisture content, right? That is very easy because now you know what is the higher heating value based on 100% dry basis. That means without any percentage of water, it is 19.22, right? So with 50% moisture content, so that means it contains, if you consider 1 kilogram of the fuel, it contains half kilogram of that particular pure fuel and half kilogram of water. So that means higher heating value with 50% moisture content is 19.22 divided by 2, right? So what is the answer? 9.61 megajoules per kilogram, right? So that is also okay. So let's put a star. Higher heating value at 50% moisture content, 9.61 megajoules per kilogram. Now next thing, so now you need to find what is the lower heating value. Now you need to find, let's write it here, lower heating value at 50% moisture content, right? That is the actual quality of the fuel, right? So let's use the same equation as I told you. Higher heating value at 50% moisture content or moisture percentage, whatever, equals lower heating value at 50% moisture content plus heat of vaporization of water, heat of vaporization of water due to moisture that is in the fuel. So now what is the moisture that is in the fuel? 50% moisture content. That means we have half kilograms of moisture or water in the fuel. Heat of vaporization of water because of the moisture content plus formation of water due to hydrogen, right? Because fuel contains hydrogen. So very easy. So now we need to find this guy. Okay. So that means we will subject LHV. So LHV at 50% moisture content equals this guy, higher heating value at 50% moisture content, this guy minus that, right? So what is this guy? You know what is this guy? This guy is 9.61, right? No problem, right? This equals this minus that. What is this one? I told you that is minus 2.4 times, that is the heat of vaporization of water times. Now there are two guys are coming, okay? Let's put two brackets like that. This is formed water. This is formed water, right? And this is the moisture content. No problem. So now let's see how to find the lower heating value of the fuel at 50% moisture content, right? So for that there is a formula, right? Low heating value at 50% moisture content equals higher heating value at 50% moisture content minus the heat of vaporization of water, right? So heat of vaporization of water mostly based upon two types of scenarios, right? The first scenario is due to the formation of water based on the hydrogen content or based on the hydrogen profile of the fuel, and the other one is due to the presence of moisture in the fuel, right? So this is the first part and this is the second part, right? So due to moisture content and due to water formation, right? So now we know the formula. So now also we know that what is the amount of heat of vaporization per 1 kilogram of water, that we know. So in order to vaporize 1 kilogram of water, the required heat energy is 2.4 megajoules per kilogram, right? So that is the rate of vaporization of water, right? So now we need to evaluate what is the individual amount of water that is formed and what is the individual amount of water based on the moisture content. All right, okay. So now we know, first of all, we have to consider 2.4 megajoules per kilogram of heat of vaporization of water, right? Then that you have to multiply by the exact mass of water, right? So now for that there is a formula, as I have taught you, that is the hydrogen percentage in the fuel, right, divided by the molecular weight of hydrogen. Molecular weight of hydrogen multiplied by molecular weight of water, right? Percentage of hydrogen in the fuel divided by molecular weight of hydrogen multiplied by molecular weight of water, right? So now let me tell you something. So now here, if you consider percentage of hydrogen in water, now again look at the fuel profile, right? So now in this fuel profile, this profile is based per 1 kilogram of fuel, right? This is based on 1 kilogram of fuel. But now actually in this scenario we have to consider the 50% moisture content. So 50% moisture content means 50% moisture, other 50% is the pure fuel, right? So that means these respected percentages must get multiplied by 50%, that means 0.5. So in that case, what is the percentage of hydrogen? So then the percentage of hydrogen will be the original percentage based upon 1 kilogram of content, which is 6.1%, but you have to multiply that with the actual fuel content when considering the moisture percentage. So that means we have 50% of moisture, means we have only 50% of the pure fuel. So multiplied by 50%, so that means 0.5. Okay, right. So that is how you should fill this, right? And when considering the molecular weight of hydrogen, let's say MH2. Now when considering the molecular weight of hydrogen, you have to consider the molecular weight per kilogram mole, right? Here you have to consider the standard unit kilogram. So molecular weight of hydrogen is 2 kilograms per kilomole, right? So like that, the molecular weight of water will be 18 kilograms per kilomole, right? Okay, so now you know the things that you have to include there, right? So now okay, so now we can fill this, right? So I will continue the thing there, right? So it is 6.1 percentage, that means 0.061. 6.1 percentage means 0.061 multiplied by 0.5, then divided by molecular weight of hydrogen, that is 2. Again we have to multiply this by 18. So I will write again. So now you know what are the things that are coming here. 0.061 multiplied by 0.5 multiplied by 18 divided by 2, right? I hope that is clear. Then the next part. So what is the amount of moisture that is there because of the moisture content? 50%. That means simply it is 0.5, right? So now you know the things, but you have to multiply. Now this is the amount of water percent, 0.5 kilograms. So you have to multiply this with rate of vaporization of water, which is 2.4, right? So now I will rewrite again, right? it is 9.61 minus 2.4 times heat of vaporization of water times, I will put two brackets because then it is easy, I can take this 2.4 out. So here 0.061 multiplied by 18 divided by 2, right, plus 0.5, right. So then what is the answer you are getting here? 7.78 megajoules per kilogram. 7.78 megajoules per kilogram. Right. Now the first part is finding the boiler efficiency, right? So what is the boiler efficiency formula? Let's say boiler efficiency neta equals steam flow rate, right? Steam flow rate times enthalpy of steam, let's say Hg, right, minus enthalpy of feed water, divided by fuel flow rate. Fuel flow rate multiplied by the value that you have calculated here, lower heating value at 50% moisture content. Now carefully look into the problem, right? So what is the steam flow rate here? Steam flow rate in the problem, if you carefully study the question, it is what is the steam flow rate here? 30.7. Steam flow rate is 30.7. What is the unit? Because you have to be very careful about the units. Kilograms per second. Okay. Because the units of steam flow rate and fuel flow rate, right, must be the same value, multiplied by what is the enthalpy of steam. Sometimes they give the enthalpy of steam and sometimes you have to find that. Oh, what is the enthalpy of steam? Let's check whether they have given the conditions of the steam. What is the condition of the steam? Steam pressure and temperature from the boiler is 30 bar and 400 degrees Celsius. So condition of the steam quality is given 30 bar 400 degrees Celsius. So you can refer the steam table. So from the steam table, the enthalpy of steam at 30 bar and 400 degrees Celsius is 3230 kilojoules per kilogram minus enthalpy of feed water. Now you have to be a bit careful in here because they have not directly given the condition of feed water, right? So the pressure after the steam turbines is 2.2 bar at an enthalpy of 2725 kilojoules per kilogram. Steam after the turbines is brought to sugar mill evaporators where the steam condensates to water. Steam condensates to water means at the end also they have mentioned the condensate is brought back to the boiler. The condensate is brought back to the boiler. That means that condensate they are again sending as feed water. That means the condition of the feed water is given. So H of feed water, the feed water enthalpy is actually the water enthalpy, right? saturated water enthalpy. This is actually the saturated water enthalpy at 2.2 bar. This is something you have to decide, right? So definitely it must be the enthalpy of water at the water enthalpy at 2.2 bar will be 517.6, right? 517.6 or 580, never mind, right? Kilojoules per kilogram divided by fuel flow rate. What is the fuel flow rate? That is also they have mentioned. Boiler is supplied with a fuel flow rate of 15.2, no problem. 15.2 kilograms per second, that is the fuel flow rate. What is the lower heating value? 7.78. 7.78 megajoules per kilogram. But be very careful. Here the units are in kilojoules per kilogram, right? So here if you put megajoules per kilogram, you need to multiply by another 1000, right? To equalize the units. Because here it's in kilojoules per kilogram, here megajoules per kilogram, so you have to multiply by 1000. So here the units of steam flow rate and the units of fuel flow rate are also same. So what is the boiler efficiency? 70.41. That is the value that I am getting, right? 70.41. That is the boiler efficiency. 70.4. What is the next part they are asking? Electrical power generation. Next part. Okay, I will solve that part here. I hope you can see the board. Electrical power generation. Let's say P electrical power. So you know, boiler produces steam, and that steam is sent to the turbine to produce electricity, right? So what is the electrical power? That is steam flow rate. Steam flow rate multiplied by the enthalpy difference between input to the turbine and output from the turbine, or the enthalpy at the end of expansion, right? The difference of turbine inlet enthalpy and turbine outlet enthalpy, right? So what is the turbine inlet enthalpy? So that is same as the steam enthalpy, right? 3230. 3230, right? Right, we'll solve that in the next line, right? Because this is the equation. Enthalpy turbine inlet minus enthalpy turbine outlet, or enthalpy at the end of expansion. So what is the steam flow rate there? Be very careful. The entire steam flow rate that is produced by the boiler is not sent to the turbines, right? So in this problem it says divided to generate, if you carefully see the problem you will get these things, 11.5 kilograms per second is consumed to generate electricity, right? So the steam flow rate is 11.5, because out of that 30.7 only 11.5 is sent to the turbines. So it's 11.5 kilograms per second. The inlet enthalpy 3230. The enthalpy at the end of the expansion, right? 2725. 2725. So units kilojoules per kilogram. Here also kilojoules per kilogram, right? So kilograms per second, kilojoules per kilogram. That means it is kilojoules per second. Kilojoules per second means kilowatt. So what is the final answer? 5,800. So your answer must be 5,800 kilowatts, right? That means in megawatts it is 5.8 megawatts. So that is the electrical power generation. So now in the next part of this problem, it says that they are using some kind of a fuel dryer mechanism, right, to reduce the moisture content. Finally that will improve the quality of the fuel, right? So they are using a dryer mechanism to improve the quality of the fuel by reducing the moisture present. So that is the next part, right? So so that means now initially the moisture content was, it was 50%. Let's say let's put a topic called fuel upgrade, right? So initially it was 50% moisture content, so now it's reduced to 40% moisture content, right? So now what is the initial fuel flow rate? So the initial fuel flow rate is 15.2. Okay, 15.2 means with 50% moisture content. 15.2 kilograms per second, right? Okay. That means, as you know, 15.2 kilograms per second. So that means per second 15.2 kilograms of the fuel is given, but it has a moisture percentage of 50%. So that means among this 50% is the actual dry fuel and other 50% is water. So that means we have actual fuel quantity of 7.6, 15.2 divided by 2, okay, kilograms per second, and water or moisture, we have moisture also 7.6 kilograms per second. So that is how the total count is evaluated, right? So now fuel quality improved. That means the moisture percentage is 40%. Now there is something. So now after improving the fuel quality, right, only the moisture content will reduce, right? So there will not be any sort of change in the mass of the fuel quantity, right? So careful. So now in this case, the quantity of the fuel mass will be the same, right? So that is 7.6, as same as in the original case, 7.6 kilograms per second. What is the moisture content? Okay, so let's say that x kilograms per second. But let me tell you one thing. Now here they say that they have improved the quality of the fuel. That means definitely this x must be, without even calculating, I can say that x must be lesser than 7.6. It must be, right? So let's calculate that, right? So now we know the moisture percentage, right? We know the moisture percentage, that is 40%, that means 0.4. So what is the formula for that? Moisture percentage equals moisture present in the fuel, moisture in the fuel, and the total mass of the fuel package, total mass, right? So what is the moisture present in the fuel in this case? Let's say you don't know that. That is X divided by total mass. So total mass will be the actual fuel content, actual dry fuel content 7.6 plus X. Okay. So if you solve that, then you will find that X is 5 kilograms per second, right? If you solve that, X would be 5 kilograms per second. Now it is very clear, as I told you previously, this X must be definitely lesser than 7.6 because the moisture content must get reduced, right? Because fuel upgrade is there. So now you know the moisture content is 5. So then now what is the total mass of the fuel package? It is 7.6 kilograms per second of dry fuel plus 5 kilograms per second of water moisture. That is how much? 12.6 kilograms per second. So now we got it, right? Okay. So now, okay, so we will erase mass of fuel package or total mass at 40% moisture content is, we evaluated that it was 12.6, right? 12.6 kilograms per second. Now there is a different story that is described here, right? So again you need to see the problem, right? Now carefully see, here they have mentioned something. Losses in the boiler has been reduced by 22%. So that means they are telling after this fuel upgrade, losses of the boiler losses have been reduced by 22%. So now that means what is the initial boiler efficiency? 70.41. Now 70.41 is the boiler efficiency as we have calculated, right? So that means what is the percentage of losses? 100 minus 70.41. So that means it is 29.59% of losses initially, right? Okay, because the boiler efficiency is this much, so the losses would be 100 minus that. So now they say after the fuel upgrade, the losses are reduced by 22%, right? That is what this reduction in boiler losses. So what is the reduction in boiler losses? Because now this is the 29.59%. So from this 22% would be getting reduced. That means if 22% are reduced, so there will be only 78% of the boiler losses based on the initial value. So this multiplied by 78% means 7800. So then what would be the boiler loss percentage that we have now? Approximately it will be 23%, right? So I can check it if you want. 29.59, right? So approximately 23%. So now the boiler losses are 23%, because earlier it was 29.59. right? So now the total boiler losses are 23%. So that means now what is the new boiler efficiency? New boiler efficiency. What is the new boiler efficiency? It will be 100 minus 23. That is 77%. Now see, there is a huge increase. Okay, so now we know because of the firewood dryer mechanism, it has resulted a reduction in the moisture content, right? Because earlier the moisture percentage was 50%, so now it has been reduced to 40%, right? That means some moisture is removed, right? So that means it can ultimately save the heat that is produced by the fuel, right? So now here also we are going to use the same boiler efficiency formula in order to evaluate that, right? So as you know, boiler efficiency equals boiler efficiency equals steam flow rate multiplied by the enthalpy difference of steam, G and H feed water, divided by fuel flow rate at improved fuel quality, right? So that means what is the improved fuel quality? Because earlier the moisture percentage was 50%. So now the quality is improved up to 40%, right? That means here you have to consider fuel flow rate at improved fuel quality at 40% moisture percentage, right? Okay, that we have evaluated, right? In the previous part I have told you how to evaluate the fuel flow rate when the fuel quality is improved, which is 12.6 here, see, right? So that also you know. And the next thing that you need to find is very carefully the lower heating value, because earlier we have evaluated the lower heating value at 50% moisture percentage or moisture content. So you need to evaluate lower heating value at 40% moisture content, right? So now this is the formula. So here our target is, now we know because of the dryer mechanism, right, the fuel quality is improved and that has resulted an increase in the boiler efficiency. That is part 1, right? We have evaluated there is an increase in the boiler efficiency, right? So that is okay. And fuel flow rate also we evaluated based on the new moisture percentage, so that is also okay. Then lower heating value, this is something that we have to find now. I will teach you how to find. Then this we know, steam enthalpy, feed water enthalpy we know. Now here we can find what is the new steam flow rate, because earlier the steam flow rate was 30.7, right? So now we are going to find what is the new steam flow rate. So from that we can get the difference when compared with the previous steam flow rate and the new steam flow rate, right? So let's calculate. So now when calculating that, there is something that you need to find. What is that? This guy. So let's see how to do that. So what is our formula, guys? Lower heating value at 40% moisture content, right? So that equals higher heating value at 40% moisture content minus heat of vaporization of water. Heat of vaporization of water due to moisture content and formation of water because of the hydrogen percentage of the fuel, because the fuel contains hydrogen, right? Let's say formed H2O, right? So that you already know. I don't need to rewrite that again, right? So now let's see how to put the values into that. So now lower heating value at 40% moisture content, that equals higher heating value at 40% moisture content. Rate of vaporization of water. What is the formula for that? You know that. That is minus 2.4 times. What is 2.4? That's actually megajoules per kilogram. Rate of vaporization of water, right? Then you have to put a bracket. You know that. And then I told you there are two members in it, right? Because this is based upon two members, right? So let's consider the formed H2O, right? The formation of water because of the hydrogen percentage, right? So now let me tell you one thing. So now what is the fuel profile according to the problem? So there is a fuel profile when the fuel is 100% dry, because the fuel profile is defined according to that. So hydrogen percentage, you know what is the hydrogen percentage? That is 6.1%, but when the fuel is 100% dry. So now if the moisture percentage is 40%, right? Moisture percentage 40%, that means 60% of pure fuel is there, right? 60% of pure fuel is there means 0.6, right? So now when considering the formation of water, because now we have 60% of pure fuel, so that means 60% 0.6. 0.6 times, let's put another bracket, 0.6 times percentage of hydrogen 6.1, that means 0.061, right? That you know, divided by molecular weight of hydrogen, right? 2 kilograms per kilomole multiplied by molecular weight of water, 18 kilograms per kilomole, right? So this part is done. So what is the next part? That means in that fuel 40% of the content is water, right? So 40% means 0.4. 40% means that's simply 0.4, right? So then what are the other values? We have to find this one, higher heating value, 40% moisture content. Okay, I will teach you how to find that. Let's put some arrow, right? Higher heating value at 40% moisture content, right? What is the higher heating value at 100% dry situation? That means when there is 100% pure fuel, what is the high heating value? 19.22, right? So now if it contains 40% of moisture, that means we have only 60% of the pure fuel. So then what is double HV? 19.22 times 40% moisture, that means 60% pure fuel multiplied by 0.6. So then now you know the value. So 19.22, right? So then 19.22 multiplied by 0.6, what is that value? 11.532. So 11.532. So I will put 11.532. I think all others are done. So now the lower heating value is 9.78. 9.78. What about the units? Megajoules per kilogram. Megajoules per kilogram. Check your value, okay? Okay, right. So now we have evaluated the lower heating value at 40% moisture content, right? Which is 9.78. So now again, by using the formula for boiler efficiency, we are going to find what is the new steam flow rate after the upgrade of fuel quality, right? Because we know the quality of the fuel is upgraded by reducing the moisture content, right? So now boiler efficiency, what is the improved boiler efficiency? That is 77%, right? 77% means 0.77, right? New steam flow rate, that is X, you don't know that, right? And that is multiplied by the enthalpy of steam. What is the enthalpy of steam? 3000 230 minus enthalpy of feed water 517.6. okay, and what is the new fuel flow rate after the improvement of the fuel quality? That also we have calculated, that is 12.6, right, multiplied by the lower heating value 9.78, but I told you here the units are megajoules per kilogram, so please multiply that by 1000, right? So x equals, by using the, so x equals 34.98 kilograms per second is the new steam flow rate, right? So what is the original steam flow rate at 50% moisture content of the fuel? That is 30.7 earlier, right? So now we have 34.98, right? So that means definitely you can very clearly see that there is a kind of an improvement in the steam flow rate. That means the steam flow rate has been increased. In when considering it as a quantity, there is an increment of 4.28. 34.98 minus 30.7 means 28 and 4, right? So 4.28 kilograms per second increase or rise in steam flow rate is there. So now in this problem it says this extra amount of steam flow rate is entirely used for the production of electricity, right? And it is very clear that there is an increase in the steam flow rate and it is directly used for the electricity production, right? So then what is the extra or additional amount of electricity production? So now what is the additional electricity production because of the rise in the steam flow rate? Let's say additional electricity production equals the additional steam quantity that we get, which is 4.28 kilograms per second, times the enthalpy difference of turbine inlet and turbine outlet. So what is it? What is the turbine inlet enthalpy? 3230 kilojoules per kilogram, minus the enthalpy at the turbine outlet, that is 2725 kilojoules per kilogram, right? So this is there is an additional electricity production of 2161.4, that means 2.16 megawatts of electricity production is there as a result of the fuel upgrade, right? Okay, so that's all about the answer. Thank you.